All right, moving right along, we are going to start our section on measures of central tendency. As we get into this section, there are some important symbols that you will need to know for this section and future sections. So I'm going to go through those first. The first symbol is a lowercase n. That indicates the sample size. A capital N, we won't see a whole lot, but if we ever do, that means the population size. An X with a small I next to it is indicating the ith data value. So it's telling you the location of the data value. So if it's X with a 1, that means the first data value, and X with a little 2 would be the second data value, and so on and so on. This symbol here is a capital sigma. And yes, I have to be specific that it's a capital sigma. And it means we're going to take the sum of whatever comes after it. This is one of the most important symbols we're going to see in this entire course. It is read as X bar, and it is the sample mean, which we're going to talk about here in a second. And then this one below it, one of the second most important symbols in this entire course, is a Greek letter. Didn't know you were going to get to learn a new language. It is read as mu, and it stands for the population mean. So X bar and mu both stand for the mean. So let's go ahead and look at what the mean is and how we calculate it. So the mean is most commonly known as the average. It is found by adding all the data values together and dividing by the number of data values. So for the sample mean, we find the X bar by taking the sum of all of the X values. So sum of all I'm actually going to call this data values because that's easier to understand. So sum of all of the data values, and then we divide by the sample size. So how many data values are there? The population mean, most of the time, if we need it, it will be given to us. But if we do have to find it, that's mu. And again, it is the sum of all the data values divided by the population size. So we have different symbols for the sample mean and the population mean, but the formula to finding them is really the same. You add up all the data values and you divide by the number of numbers that you just added together. So we're going to do a couple of examples. The first one, we have a data set of exam scores for a sample of 6 students from a statistics course. We're going to calculate the mean exam score for these students. So because it is a sample, that would be X bar. And we're going to calculate the mean by adding together all of the numbers. It doesn't matter what order I write this down in. Ooh, that's a funky looking 8. And then we're going to divide that by the number of numbers, which is 6. Now, it's really important that we remember our order of operations. We want to make sure we do all the addition before we divide. So if it helps you to remember, that top part should go in parentheses. So I'll give you a second to do that calculation. And you should get 78. So this means that the mean score for these 6 students was a 78. Not too bad. Add everything together, divide by the number of numbers. Let's do one more example. Suppose there was a 7th student as a part of this sample who did not take the exam, therefore they scored a 0. Recalculate the mean exam score if we include this 7th student. And then what happens to the mean score when this low score is recorded? Okay, so it's still a sample. I believe it doesn't tell us that it's not. And then we have the 6 students from before. And then now we have an additional student who scored, unfortunately, a 0. And then I'm going to divide that by, oh, not 6, by 7, because now I have 7 numbers up top. So I divide by 7 on the bottom. So I'll give you a second to calculate that. If you need more time, please feel free to pause the video so that you can do the calculation. And now the answer for that one turns out to be 66.86. And here, as a general rule of thumb, on rounding, two decimals or one more decimal than the data contained. So this data set didn't have any decimals in the original numbers, so we're going to do 2 decimals. If we have a data set where we're given data values and they already have decimals in the data set, we want to give one more decimal than the data set already gave us. And when we have instances like that in the notes, I will make sure and point that out. So now what happened? When we had the 6 students, the mean was a 78. But now with 7 students, the mean is a 66.86. Well, what happened is the extreme value of the 7th student that caused the mean to get pulled down quite a bit lower. right? We started at a 78 and now we've dropped down to a 66. That's 12 points lower by including that zero. So extreme values, either extremely low values or extremely high values, can have a big effect on our mean. And that is how we calculate the mean, and that is the effect of extreme values.